Alright guys, so in this video I wanted to talk about stretches and reflections. So what are stretches and reflections? Well, stretch is where you have a function. Let's start with our base function. Let's just make it a parabola in this case. And if you were to stretch it horizontally, so you were to make it fatter or horizontally make it skinnier, that would be a stretch. And also if you were to make it taller or shorter, that would be a stretch vertically. So, man, it's going to get confusing, but basically, when you make it taller or shorter, that's a vertical stretch. And if you make it fatter or skinnier, that's a horizontal stretch. And reflections can either be over the x-axis or the y-axis, and it's exactly how it sounds. It's a reflection. So for example, if we made a reflection like this, that would be a reflection over the x-axis. And then if we reflected it across the y-axis, that would be a reflection across the y-axis. Alright, so that's just getting started. But we'll do some examples just to make sure, just to give you guys a better understanding. Okay, so let's say we have the function 3x squared. Okay, and so it's right here. Okay, and we wanted to make it 2 times as fat. Right? How would we get the equation for a function that was 2 times as fat as this right here? Well, let's look at the coordinates to really understand that, to find that out. Let's say this is 1, 3, or sorry, negative 1, 3. We're on the left side, negative 1, 3. And then this would be 2 times as fat, so negative 2, 3. All right. So when we plug it in, when we plug in negative 1 to this function, we do 3 times negative 1 squared is going to equal 3. Right, it works. But if we were to plug in a negative 2, it would definitely not work, right? It does not equal 3. Okay, so we would have to sort of change this in some way to make it so that it does equal 3. And we know that this is 2 times too big in magnitude, right? This is always going to be 2 times too big in magnitude to get the correct y value. Your x value is always going to be 2 times too big to get the right y value. So what we're actually going to do is we're going to divide it by 2 and see how that works. Okay? So if we divide our x value by 2 before we plug it in, how does that work? Well, we would get 3 times negative 1 squared, which does indeed equal 3. So that would work. So our new function could be 3 times x divided by 2 equals, well, let's just call it g. Our new function g is going to be 3 times x divided by 2, squared. All right. So perfect. That's what you have to do to get the equation of something when you're making it fatter. You're going to divide it by whatever amount that you made fatter. So if you doubled it, you would divide it by 2. If you tripled it in fatness, you would divide it by 3. And let's try one with making it skinny. Okay? If we wanted to make some sort of function skinny, let's say we have our f, and let's say it's 3x this time, and 3x, and we wanted to make it really, really skinny. So that just means that it would be skinnier than before. So it would have a much steeper slope now. Let's make it 2 times as skinny. Then what we would do is we would do 3 times 2x, okay? Because what we're doing is we're making it smaller. Every single x value is going to be too small now. So we need to multiply it by 2 so that we're multiplying 3 by the correct value to get the correct y value. Okay? So that's what we would do for making it skinny. We would multiply by how much we were making it skinny by. So if we were making it double as skinny, so half as fat, we would multiply it by 2. Or if we were making it 3 times as skinny, we would multiply it by 3, the x value. In the contrary, we for making it fatter, we would divide it by that value. Okay, so those are horizontal stretches, okay? But what would a vertical stretch look like? Well, let's go back to our usual sort of parabola function. We have just 3x squared again is going to be f. And we wanted to make it double its height, okay? So we wanted its height to be doubled. How would we do that? Well, we know that f of x equaling 3x squared is going to be the same thing as saying that y equals 3x squared, right? So we want to make y double what it was before, right? So we would say y equals 2 times 3x squared. So instead of multiplying x, we're multiplying the whole function to make y double as big. If we wanted to make it shorter, we would divide it, right? So we would say y, let's make it half as tall as it was before, so double as short, I guess. 3x squared divided by 2. That's what we would do. Okay. So those are a lot more simple than the horizontal stretches, in my opinion. What about reflections? What do reflections look like? Well, let's start with an example. Let's say we had our function f, and it was equal to x squared, and we wanted to reflect it across the x-axis. Okay? What would that look like? Well, we know that this is going to be equal to y equals x squared. It's the same thing, right? Saying f of x equals x squared is the same thing as saying y equals x squared. And we want y to be the negative of what it once was. So if it was this here, right? It's like, let's say it's 2 here. We want the new one to be negative 2. We want it to look like this. We want it to be reflected across the x-axis. For every single y value, we want it to be negative. We can do that by saying y equals negative x squared. Okay? Now, what if we wanted to reflect a function across the x-axis? Oh, sorry, across the y-axis. What would that look like? Well, let's say we have the function. You know what? Let's just say y equals x. So f, the function f is just equal to x, regular plain x. If you wanted to reflect it across the y-axis, you would want every single x. So for example, let's say this is going to be equal to 2, comma 2. If you had reflecting it across the y-axis would look like this, right? And it would look like this now, negative 2, comma 2. Now when you plug in negative 2 into the function x, so negative 2 does not equal 2, right? So how would we fix that? Well, we would just say, we would have to put a negative at the front. So we would say negative x. That's going to be our new function. We have to say negative because it's been reflected and now it's negative. And because it's negative, it won't get the same values as before. So we have to say negative x now. So g is now going to be negative x. So again, for every single value, x is going to be on the negative side now. So it won't be, the x value won't be correct in order to get the right y value. So we have to say negative x. We have to put a negative in front of the x. Okay, so let's do another example just in case. Let's say we have the function x squared. Okay? Let's just say that's f. And I'm going to put that on our graph. And it looks like this, right? Okay. let's say we wanted to reflect it across the x-axis, okay? We wanted to reflect it across, sorry, the y-axis, my bad. We wanted to reflect this function across the y-axis. All right. So what would happen here? Well, sorry. G, what is G going to be? Well, we know this over here is going to be switched to over here. This over here is going to be switched to over here. Now this is a symmetrical function, so when we take a reflection across the y-axis, it's going to be the exact same. So although it may seem like we're going negative x squared, when you square something, it ends up being positive anyways. So this negative doesn't really change anything because you're always going to be squaring it, and it's not going to be changing anything in the function. So I just wanted to bring that up. All right, now let's do another example of a constant slope being reflected across the y-axis. So let's say this is going to be equal to 2x, okay? F is going to be equal to 2x. And we want to reflect it across the y-axis. Well, it would look like this, right? And for every single x value, so let's say this is negative 2, and this is positive 2. If we were to multiply 2 by 2, sorry, this is 2 comma 4, this is negative 2 comma 4. If we did multiply 2 times 2, it would get 4, right? But if we did negative 2 times 2, so 2 times negative 2, that's not going to get you 4, right? So we have to do something to our x value, and what we have to do to our x value is we have to make it negative. We have to cancel out the negative that it was before, right, to fix it. So 2 times negative negative 2 does indeed equal 4, all right? Okay, so those are reflections, but there is something important that you need to know about reflections. When you are taking a function, so let's say a reflection of a function, we have f equals x squared again, and we wanted to reflect across the x-axis like this. Whoa, that does not look... Okay, that's supposed to be symmetrical, but clearly it isn't. But that's what it's supposed to be. Just use your imagination. So when you reflect it across that x-axis, you're basically saying that y is going to be a negative of what it once was, right? So we're basically saying y equals negative x squared, okay? But when we reflect it across the y-axis, we're changing the x. So we would have to say negative x in brackets squared. They're very different things. So you have to keep in mind that when you're taking these reflections, when you're reflecting across the y-axis, you're changing x itself. And when you're reflecting it across the x-axis, you're changing the whole function. You're putting a negative in front of the whole function. Whereas here, you're only changing the x. You're replacing the x. So that's all that we have for this video. I hope that you guys found it interesting. Thank you.